Hey there, I'm going to make a quick video to update my blog and tell you about it. It's kind of a continuation from this one. I made a video about this as well, observations at Fire Island Lighthouse. So this one today is from the other side. Over here in New Jersey, I'm at a place called Washington Rock at this nice scenic outlook where you can really see pretty far. It gives you an idea here. I'm using this app called Theodolite on my iPhone, and it's not for making precise measurements, but it's a pretty nice reconnaissance tool. It'll give you a position, it'll give you an altitude, gives you the bearing, and you can take pictures using that app, and you can get your vertical angle as well. So I threw that in here as well, and I gave you the link to where you can get that app. So here's me precisely leveling this T2 theodolite. There's the level vial. I also made adjustments to the vertical circle compensator, which you should do periodically, especially as the seasons change with temperature variation. You got to keep your instrument maintained to give you the kind of repeatable precision that you expect from this type of an instrument. See, so here I'm providing you with the position that I determined over in the park at Washington Rock Park. There's the latitude and longitude and the elevation. I measured the height of the theodolite at that position, and I come up with a telescope elevation of 508.4 feet. Here's a picture looking at the Empire State Building with the telescope set to be horizontal. So what you're looking at is my horizontal plane extended out to the Empire State Building. I'm guesstimating that I'm hitting at the 95th floor. I give you a link to a picture of the building. You can see I'm hitting right about here. I count the floors down. Whether it's the 95th floor or not, you could see this is about where my telescope crosshair is hitting that building. As you can see right there. Let's see what else. Here I give you the distance, 27.2 miles. I also measured the zenith angle to what I could make out as being the spire. And I give you the NGS data sheet for the Empire State Building. Here's a close-up zoomed-in view of where my crosshair, horizontal crosshair, is intersecting the building. Next, I'm showing you my telescope trained on the blinking light at the One World Trade Center. There's a picture of the blinking light, what that looks like. So that's what I'm able to see. And I measure a zenith angle there. I actually measured 4 sets of phase 1 and phase 2 pointings. So I give you my standard deviation and the standard error of the mean of that zenith angle. Here's a picture of the crosshair at 90 degrees, horizontal basically. And again, here's the elevation of the theodolite. And I'm looking at the building 25.0 miles away. And I'd say, I'm definitely more than halfway up the building. I give some links to some sites that give you the height of the One World Trade Center and other information about it. Currently, there's no NGS data sheet on that building, so I am giving you a privately determined position. Here I'm going to talk about the computations where I've combined the observations made from Fire Island Lighthouse over to the Empire State Building and what I labeled as the Freedom Tower in here. It's One World Trade Center. And then here I am in this park making these observations. And I provide the reductions, basically, just rough approximations on a spheroid. So these are computations on a sphere, not the ellipsoid. And I'm giving you from Fire Island Lighthouse to the Empire State Building, from Fire Island Lighthouse to One World Trade Center, the delta elevation, the arc, the delta arc in minutes and seconds, and the drop of the curve down from the horizontal plane at the standpoint. So this is the standpoint, that's the 4-point. Next, I give you from Washington Rock to, well, I should really zoom in on that, shouldn't I? Let me do that a little better. Let's try it this way. All right, yeah, that's better. Again, basically what I was saying, the standpoint, the elevation of the standpoint, here's the 4-point, and there's the elevation. That's the delta elevation, and this is the delta arc from one geographic position, from one set of latitude and longitudes to the other latitudes and longitudes. If you inverse those, it's almost like a Pythagorean theorem on arc measurement. It's a rough approximation. Here's the miles, and this is the drop down from the horizontal plane at the standpoint. That's the way you compute the 8 inches times the miles squared. Okay, that calculation is not something over the horizon. It is from the horizontal plane established at the standpoint or the observing point. And then here is Washington Rock to the same buildings. Okay, and then I give you the full from Washington Rock all the way out to Fire Island Lighthouse. It's almost a whole degree. It's 57 minutes. It's about 66 miles away, 65.8. The drop there is 2,900 feet from that extended horizontal plane, down like that. So that's basically what I'm throwing up on the blog. And I'll show you the project in my software. Let me turn off. Here you could see the New Jersey triangulation diagram, and I have got on here the nautical chart for that inlet. And I'll turn those off. Okay, so here we have, again, the angle observations made from Fire Island Lighthouse to the Empire State Building and the Freedom Tower, and then on this side here to both buildings. I'll tell you right now, when you consider the way this is kind of a weak intersection for the horizontal, the vertical is decent. I've got pretty good vertical values on what I could observe, what I could see. But to really pin these down horizontally, you would really need to intersect it from a point over here, and then preferably like from a point over here. That, let me turn on the triangulation diagram again. If you look at these triangulation stations, they're observed from numerous positions surrounding them, and that's how you get a nice tight horizontal position. So I mean, I only have so much time to do this stuff, so I don't have very strong horizontal solutions here, but it's close enough. I mean, it's good enough for what I'm doing. The vertical is what I was interested in, and I think I definitely obtained that. Tell you what, let's look at this in Google Earth, and you'll see what I'm talking about. Where are you, Google Earth? Right there. Send that over. Okay, so whoops, here I am over at the lighthouse. Yeah, you could look at the previous video about that and the blog entry for that. And here's the angle measurements. To the two buildings, and then here I am over in New Jersey, actually closer to the buildings from this park. And that's right where I was, in this corner right there. So back up to the buildings, you'll see what I'm talking about. My horizontal intersection is a bit weak, just geometrically. This is not the strongest solution. So I'm coming up with a position here. It's in Google Earth, it appears to be here. Okay. And same thing for, Empire State Building. To do a better job of the horizontal positioning, you'd have to go, like something from over here, maybe something from up in here. I don't think I'll be doing that. I've achieved the goal that I had. And so that's it. I'll discard that. And back to the blog. Oh, did I shut that down? Anyway, I will leave a description to the blog so you can see this video from the blog, or from the blog you can see the video, or you can, from the video, you'll be able to get to the data, however you happen to find this. And if you like what you're seeing, I have more of these in the works. I have one where I went to a lake and used the lake as a level, and I'm putting that together. That's going to be probably my next video. Feel free to share these and subscribe to my channel. I've got a few more of these to go, and that's it. I'll say so long for now. Thanks for tuning in, and take care. Bye.